So coming up to our fourth absolute value function, and this time we've got two separate absolute value brackets and then a third part whose value where the value doesn't change. So we're going to do the same thing, but this time I want to label those three parts. I'm just going to call this first term or this first part A. So let's come in here, we'll call that A. We'll call this second part, which includes the minus out the front, B, and we'll call the third part C, just so that we can deal with that separately below. And we're still going to go the what and the when or domain. So the first part, we'll just deal with the first part A, y equals 2 times x plus 1. When does that apply? Just for this first part, when x plus 1 is greater than or equal to 0, or x is greater than or equal to minus 1, and that's 2x plus 2, expanding that out. And if you like, that's the first part. And then if we have a look at the second part, when this is less than, when this top part here is less than 0, so we've got y equals minus, or if you like, 2 times minus x plus 1, just to take the negative of the bracket, that equals minus 2x minus 2. And when does that occur? When I'll just put it straight here, x is less than minus 1. You can see when x plus 1 is less than 1, x is less than minus 1. Okay, coming to B, and this time the absolute value of x minus 1, and we're subtracting that. So what does y equals? Y equals minus x minus 1, the minus outside of the absolute value, and then the positive x minus 1 when x minus 1 is greater than or equal to 0, so x is greater than or equal to 1. And that's minus x plus 1. And the second part, when the contents of our absolute value bracket are less than 0, so y equals minus, and then we've got minus x minus 1. So we've taken minus the absolute value bracket, and we've got the minus stays outside the absolute value, and we'll simplify that. And when does that occur? When the x minus 1 is less than 0, so x is less than minus 1, which x is less than 1. Okay, so let's just simplify the function for y. Y equals minus x minus 1 is simply x minus 1. The two minuses cancel out. And so there's our second function for the part that we've labeled B. And then C is always minus 1 for all x, no matter what x is. So let's just have a look at that. We've got two conditions, or two sets of conditions. We've got x is greater than or equal to minus 1, x is less than minus 1, x is greater than or equal to 1, and x is less than 1. Let's just draw that on a number line here. I'm going to put x is 0. I'm going to put a little dot here, a little line here, x is 1, and 1, 2, x is minus 1. So we've got, if you like, one condition when x is greater than or equal to minus 1. I'll just put that there. Bring this down a bit, and x is greater than or equal to minus 1. And there's your first condition. And then you've got x is greater than or equal to 1. Let's just put that in here. And I'll put a line through there. And so we've got here x is greater than or equal to 1. We've got here x is less than minus 1. And between these two, we've got minus 1 is less than or equal to x is less than 1. So we've got now 3 regions here, and we can go back and visit each component of the y value to get the y value for all of those 3 regions. So the first region that we'll look at, x is greater than or equal to 1. When x is greater than or equal to 1, this first part here, that's the top part we'll use, 2x plus 2. For this second part, if x is greater than or equal to 1, again, it's the top part we're using, minus x plus 1. And the third part here, it doesn't matter what value of x, we always subtract 1. So y equals 2x minus x is x, plus 2 plus 1 minus 1, x plus 2. And that's our first equation, or first part of our equation for y. Next region, when minus 1 is less than or equal to x is less than 1. What about the top part? We're greater than or equal to minus 1, so it's 2x plus 2. The next part, we're greater than or equal to minus 1, but we're less than 1. Greater than or equal to minus 1, but we're less than 1. So it's the second part here. Plus x minus 1, and the third part is always minus 1. So that gives us 2x plus x is y equals 3x plus 2 minus 1 minus 1. The constant term falls away, so y equals 3x. And now the third part, when x is less than 1, when x is less than minus 1, I should say, we've got x is less than minus 1, we've got y is minus 2x minus 2, less than minus 1 here is plus x minus 1, and for the third part, minus 1. So y equals minus 2x plus x is minus x, minus 2 minus 1 is minus 4, minus x minus 4. So there are 3 equations, and now we can put together a table of values. So now we put in our axes for graphing, and we've got 3 lines depending on where we are in the domain. 3 lines depending on the x values. So let's start with the first one, and we'll put table of values. We need 2 points to draw a straight line. So the first one, y equals x plus 2, and that applies when x is greater than or equal to 1. So we'll put in x equals 1, 1 plus 2 is 3, and we'll put in x equals 3, 3 plus 2 is 5, and I'll just label this 1, and I'll make this x equals 2, so we'll use 2 jumps for each one, y equals 1, y equals 2, and so on. So we've got 1, 3, and that's our point 1, 3, and we've got the point 2, 5, so 2, 5, and there's our first line straight through those 2 points. There's our first line. We'll just bring that across a little bit. And the next one is when minus 1 is less than or x less than 1, we've got 3x, so y equals 3x, and we'll pick x equals 0, 3 times 0 is 0, 0, 0, and we'll pick x equals minus 1. When x equals minus 1, 3 times minus 1 is minus 3. We've got minus 1 and 1, 2, y equals minus 3. And we'll just change that color, and we'll draw that as a green. And there's our second line segment. And now our third line segment, we've got when x is less than minus 1, it's minus x minus 4. So let's put minus x y equals minus x minus 4. and we can pick when x is less than -1, let's say -2, and x equals -4, minus x minus 4 minus -2 is 2 minus 4 is -2, and when x equals 4 minus -4 is +4 minus 4 is 0. So let's draw those in, and we'll make this one a purple. Don't know what happened there. Let's go back here. We'll make this one a purple. And we've got -2, -2, 1, 2. I'll put y equals -2, x equals -2, and there's our first point, and -4, 0. When x equals -4, y equals 0. And we can now draw our third line, and this is y equals -x minus 4. Our second line segment was y equals 3x, and our first line segment was y equals x plus 2. Y equals x plus 2. And there we go. We just followed each step, the what and the when. The complication here, we needed to look at two conditions. X is greater than or less than 1, and x is greater than or less than -1. And then we just followed through the rules, produced a table of values, and there's our graph. So to really build your understanding of absolute value graphs, you want to look at some of these examples and say, what would it look like if I changed some things around? So for instance, what if I made y equals minus 2x plus 2, y equals minus 2x plus 2 instead of 2x plus 2? Well, then the line or the value inside the absolute value will always be positive, but the minus outside means it'll always be negative. So if you followed that through, when x is greater than or equal to -1, instead of 2x plus 2, it'd be minus 2x minus 2. And when x is negative, it would be plus 2x. So it would always bring it down here in the negative, and you'd have, if you like, that upside down v, which should be drawn exactly the same as the right way up v. And what if we looked at another example? What if we made 2x plus 2, which is y, what if we made y equal a given value, such as y equals 3? Let's have a look at that. Y equals 3, 1, 2, 3. It's along this line here. There's your line of y equals 3. So what does x equal when y equals 3? You can see from the graph that x equals a half, or when y equals 3, x equals, we'll just bring that down, x equals -2.5, and you could put that through the equation. 2x plus 2 equals 3. When x equals a half, 2 times a half plus 2 equals 3. When x equals -2.5, 2 times -2.5 plus 3 equals plus 2 equals -5 plus 2 equals -3. But remember, we've got the absolute value sign around that, so the absolute value of -3 equals +3.